Hey friends, in this video we're going to go over the next section of your study guide. On the screen you can see the answers to numbers 18, 19, 20, and 21. And in just a second I'm going to show you the answers to the rest of tonight's homework. Pause if you need to so you can check your work. Here are the answers to number 22 and 23. So now we're going to go over each problem so I can show you how to get the right answer and you can check to see if you used the same method as me. Let's go. Alright, so problem 18 says, Miss Ross has 3 students who earned the most stars on USA Test Prep. She gives them 1/3 of a cookie cake as their reward. If the students share the cake evenly, how much of the cookie cake will each student get? So, what I have is I have 1/3 of a cookie cake. And that's going to be shared between my 3 students. So if I would like to do it models first, I'm going to draw my cookie cake and represent that I only have 1/3 of it. If I share that between 3 students, I need to split it into 3 pieces, and this right here is what 1 student will get. They will get 1 out of the 1, 2, 3, 4, 5, 6, 7, 8, 9 pieces. To solve this using the algorithm, I would need to use the equation 1/3 divided by 3. And then we say, keep the first fraction, keep it the same. Ain't no reason to alter its name. Change the op symbol, it says to divide. Change it around, multiply this time. Flip the last fraction, flip it around. Reciprocal works better, or so I have found. Multiply the numerators, multiply the denominators. Simplify if necessary. That's how you multiply fractions. So there you have it. Whether you use models or the algorithm, you should get 1/9 of the cake as your answer. Number 19, Miss Roundtree has 8 cups of hot chocolate. She only has a 1/4 measuring cup to scoop it out into individual mugs. How many mugs was she able to put hot chocolate in? Will it be enough to share with her 28 students? In this problem, Miss Roundtree has 8 cups of hot chocolate. She's going to be scooping them out into individual mugs using a 1/4 measuring cup. So if I want to use models, I'm going to represent my 8 mugs. 1, 2, 3, 4, 5, 6, 7, 8. And I know that I can get 4 scoops out of it if I'm using a 1/4 measuring cup. So I'm going to split them up into fourths to show that I get 4 scoops out of each one. And then all I have to do is count my scoops. 4, 8, 12, 16, 20, 24, 28, 32. So that's how we would solve it using models. Now let's look at the algorithm. Miss Roundtree has 8 cups. She's going to be dividing it up into groups of 1/4. We say, keep the first fraction, keep it the same. Ain't no reason to alter its name. Change the op symbol, it says to divide. Change it around, multiply this time. Flip the last fraction, flip it around. Reciprocal works better, or so I have found. Multiply the numerators, multiply the denominators. Simplify if necessary. That's how you multiply fractions. So whether using models or the algorithm, we see that we can fill up 32 mugs. So yes, she does have enough to share with her 28 students. Moving on to number 20. Audrey has a piece of string that is 6 feet long. She wants to cut it into 7 equal pieces. How long will each piece of yarn be? So in this problem, Audrey has 6 feet of yarn. She's going to be cutting or splitting it up into 7 equal pieces. So I would take my 6 feet and I would split it up into 7 equal pieces. We know that fractions are division, so the answer to 6 divided by 7 is simply 6/7. Every piece will be 6/7 of a foot long. Number 21, write a division problem that means the same as 4/5. We know that fractions are division, so 4/5 is the same thing as 4 divided by 5. You could have also written if you would have liked. All right, moving on to the last couple problems. Cade's mom made a huge pan of macaroni and cheese last night. After dinner, there was 1/6 of the pan left. 4 of his friends heard his mom made the macaroni and cheese and immediately came over to eat some. How much of the macaroni and cheese will his friends get? To model it out, I'm going to model my pan of macaroni and cheese. I'm going to split it into 6 and show that there was only 1/6 of a pan left. In comes his 4 friends, so we're going to split this up into 4/4. And we're looking at what one friend would get. So they would get this piece right here, which is 1 out of the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. 1 out of the 24 pieces. If we want to use the algorithm to solve this, we would say that we have 1/6 of a pan, and we're dividing it up between 4 friends. We say, keep the first fraction, keep it the same. Ain't no reason to alter its name. Change the op symbol, it says to divide. Change it around, multiply this time. Flip the last fraction, flip it around. Reciprocal works better, or so I have found. Multiply the numerators, multiply the denominators. Simplify if necessary. That's how you multiply fractions. So whether we use models or the algorithm, we can see that his friends would get 1/24 of the pan. The last problem says, there are 12 students with iPhones in Miss Roundtree's class. She took up 2/3 of the iPhones due to the distractions. How many iPhones did she take up? So you can see here I used the models provided to me, and I saw 1, 2, 3 rows. So I said this is 1/3, this is 1/3, and this is 1/3. If she's going to take up 2/3, she's going to take up 2 rows. And then I counted 1, 2, 3, 4, 5, 6, 7, 8. So she's going to take up 8 iPhones. If we wanted to solve this mathematically using an algorithm, she would take up 2/3 of the 12 iPhones. We know of means multiplication, so I'm going to put my 12 over 1 and then say multiply the numerators, multiply the denominators, simplify if necessary. That's how you multiply fractions. 3 can go into 24 8 times with no remainder. So whether we used the models or the algorithm, we can see that she would take up 8 iPhones. And there you have it. Those are the problems from tonight's homework. See you tomorrow.